My name is Manuel Rodriguez, and I will present application of DevOps data in the management of software teams. This presentation is divided into the following content. First, I will start explaining my research questions. Then I will go into the DevOps maturity and why is this so important. Next, I will go for DevSecOps and why it was important to start shifting the project from DevOps to DevSecOps. Later, I will talk about the implementation of the ELK stack in the project, followed by the approach that I'm taking for the research, and lastly, about the milestones in the project. So we have three main research questions. The first one is how to maximize the data collection process from each stage of the pipeline. The second one is which DevOps stage produces the most valuable data. And the third one is how to correlate the extracted data into data-driven business decisions. Regarding DevOps maturity, a company is only ready for DevOps when they have culture and strategy, because DevOps has to be recognized as a culture-driven program that draws different teams, pushing them towards a mutual goal. And the transition to DevOps involves a change in the organization's working culture, and this is supported by a set of methods and frameworks, so that it requires a proper planning and a comprehensive procedure. The second one is the automation, because automation is code to continuous delivery and continuous deployment tools. By automating monotonous tasks, the automation process helps development, experimentation, and production in a DevOps series, thus preserving time and improving resource efficiency. Later is collaboration and sharing. This is the most significant aspect of DevOps culture, because collaboration and sharing are essential to DevOps and teams in the same location. And lastly, we have the structure and processes, because every modern day IT function is process-oriented, and this includes the lifecycle. This is developed in DevOps context, where all the platforms are a set of plans that are in line with corporate policies and business intentions. The main stages from DevOps that we're focusing on the research are the build stage, the deployment stage, and the operation stage. In the build stage, once a developer has finished a task, they commit their code to a shared code repository. There are many ways this can be done, but typically the developer submits a pull request, a request to merge their code with the new shared code base. Then another developer then reviews the changes, and once they're happy and there are no issues, they approve the pull request. And the operations basically is monitoring phase, which involves recording and processing of key information about the application to deduce the areas where more efforts are required, as well as the general patterns. This is an operational phase, and the objective is to enhance the software application operational efficiency and also continuously monitor the performance of the application. Hence, this is a very crucial phase. The DevOps project was in the dire need of some security policies. That was the idea of adopting more of a DevSecOps model. In this case, DevSecOps refers to the integration of security practices into DevOps. The foundation is a culture where development and operations are enabled through process and tooling to take part in a shared responsibility for delivering secure software. So what started as a loose collection of common practices shared among high-functioning software engineering teams transformed into a modern statement of engineering culture and process. And this is DevOps. And organizations with a shared responsibility of development and operations are able to iterate faster and as a result are more successful. So DevSecOps extend the philosophy of coding security objectives as a part of our goal structure, and DevSecOps should be thought as a natural continuation of DevOps, rather than a separate idea of concept. Some of the benefits of adopting the DevSecOps model is, first of all, a faster delivery, because the speed of software delivery is improved drastically. Later is the improved security posture, because security is a feature from the design phase forwards. Later is the reduced cost, because identifying vulnerabilities and bugs before deploying result in exponential reduction in risk and operational costs. Then we have the enhancing of the value of DevOps, because improving overall security posture as a culture of shared responsibility is created by the integration of security practices into DevOps. Then we have the improving security integration and pace, because cost and time of secure software delivery is reduced through eliminating the need to retrofit security security controls post development. And later we have enabling greater overall business success, because a greater trust in the security of development software and embracing new technologies enables enhanced revenue growth in expanded business offerings. So in order to get more into the benefit of DevSecOps, we decided to migrate the standardized monolithic approach that we had from the previous architecture into microservice architecture. In this graph, we explain a little bit more how everything works. We have a Kubernetes cluster where we have our main cluster that's in charge of the pods, where we have all the logic from the various systems, and all of these are obviously deployed to Docker. In order to get the most amount of data from every single one of the stages, I deem fit to implement the what is known the ELK stack or the Elastic stack, because from Elastic stack we get the information from the logs, we get the data processing from using Logstash, and we get the storage features that Elasticsearch provides, and we got the reports that Kibana provides. Basically, the ELK stack is popular because it fulfills a need in the log management analytics space, because this allows us to monitor modern applications from the whole IT infrastructure where it's deployed, and requires a log management that is exactly what we require for the management of teams, for the analytic solutions that enables the engineers to overcome the challenge of monitoring what are highly distributed, dynamic, and noisy environments. But in order for the system to work, there was a need to implement like a middleman between the ELK stacks. First, we're going to be using the bit software for the data collection. Then I'm still in the process of deciding what is the best approach to introduce like a system for like an event system for either can be used Redis, Kafka, or RabbitMQ, because for handling a more complex pipeline built for handling large amounts of data in production, and additional components are likely to be added. So the approach that I'm trying to follow for the research is first like the evaluation of the existing tools in the market. This taking into account all the tools that I'm using for the different stages of the DevOps, including the ELK stack, Kubernetes, and many others. The second one is international security practices, in this case the shift that I'm trying to make into DevSecOps. The next step is the design of the microservice architecture. Later, the creation of clusters for development environment. I'm trying to see if this is the only cluster that I'm going to require. Later is the implementation of the monitoring tool. In this case, is the whole application of the ELK stack, followed by the collection of data from each of these stages. And as a last step is the analysis of the data that I will get. In the meantime, as a bonus, there was a paper published. This paper was is a survey on data science techniques for predicting software defects. And basically, like, this is the timetable for the activities that I'm taking that I took this semester. Basically, like from December to February, there was a review of all the automation tools in the market. This included tools for the staging, for the testing, for the deployment stages. And from January to May, there was a need of polishing the previous established research questions from previous semester. Then it was the development of microservices from the trying to compartmentalize like the logic behind the applications that I'm working, and trying to migrate them into microservices, and later the creation of a cluster of development. This cluster is developed in Kubernetes. and everything is stored with Docker as well. From June to December, I'm trying to implement the Elk stack. I'm still trying to figure out when it's the appropriate stage where I can implement, or if I can do this across all stages with all the tools that I'm using. Once the implementation is done, I'm going to proceed to analyze the data that I'm getting from the logs. And for 2022, I'm trying to start working on the first draft. So on the first quarter of 2023, I will have the second draft, and on the second quarter of 2023, I'm planning to have my presentation. And mostly, like, the challenges that come in the research, they come from balancing developer tools choice with the need to reduce the fragmentation and training and security overhead. Then is to find the performance issues in the applications, because it's very difficult to understand this new technology for me at the moment. Also is the misunderstood metrics and how metrics can impact each other. Then it comes from the lot of time being wasted setting up the data for the development cluster, and obviously, like, the steep learning curve for all the tools and everything that I'm working on. And that's the end of my presentation. Thank you very much for your attention.